Hi, everyone. My name's Lesa Vaughan, and I'm a Senior Account Manager with IMAGINiT Technologies. Welcome to Building Transformations Project Series Stories, and thank you all for taking the time to join us today. So without further ado, I'd like to get into today's project story from EastPoint Engineering. The Angus L MacDonald Bridge, leveraging SCAN to BIM to asset management. So today's story is based upon Halifax's iconic bridge, the Angus L MacDonald, which we affectionately call the MacDonald Bridge here locally. To prepare you, I want you to imagine the challenge of managing a bridge from a maintenance perspective, but particularly one that's 67 years old, and doing so without the benefit of some of the project deliverables you might expect to get today, like a model. So basically, you're starting at the very beginning. Today, we're going to share the challenge of accurately modeling this bridge to assist the owner, Halifax Bridge Commission, in making better engineering and maintenance decisions. Hear about the challenges in collecting the accurate data on a bridge that is in constant motion, and see the final result that made all of this possible, and only possible by leveraging scanning technology and trusted workflows that made this company able to provide a level 300 and above model. And finally, understand how the customer might plan to use this data and what it could be used for in the future. Today's presenter is Simon Sankey, Director of Strategic Technology and Quality Manager at EastPoint Engineering. EastPoint is based here in Halifax, and I'm proud to say they've been a customer of mine for many years. Our time together has spanned a few, I guess 5 to 7 years. And in that time, I have seen this company grow exponentially. And I think that that's due to two key things. One, they recognized early the value of BIM and what it would bring to their customers by improving their project outcomes. And two, they recognized how LiDAR scanning would jumpstart nearly all of their projects and the power that a point cloud can offer to owners after the design and the construction is complete. So it is my greatest pleasure to welcome Simon Sankey to share the story about Halifax's iconic bridge and their project. Simon, the floor is yours.
Thank you, Lesa. Thanks for the intro. As Lesa says, I'm the Director of Strategic Technology, EastPoint, formerly the BIM Manager, and my presentation is called Scan to BIM to Asset Management. We were presented with a unique opportunity to apply BIM, and I say unique because the Halifax Harbour Bridge Commission, the chief engineer, was at a bridge conference, a bridge owners conference in San Diego a few years ago, and stood up and sort of asked the audience, what are you doing for asset management? And everyone kind of looked around and said, well, we'll wait and see what you do. So they knew Hassan Chowdhury, the chief engineer, had a plan. And so he reached out to me, and our task was to scan and create a BIM model of the MacDonald Bridge. As Lesa says, a really iconic piece of infrastructure in our fair city of Halifax. It's the link between the Halifax Peninsula and Dartmouth. So let's take the scan to begin with. There are several methods we could have used to achieve the scan and capturing the required data. Laser scanners, Pro Series scanners, drones we considered, but they weren't that prevalent at the time. There weren't these drones that you get nowadays with gimbals that can carry your scanner and things like that. But we weren't sure whether we'd capture the data in a format that was interpreted clearly in the BIM modeling environment. So we took our RTC 360, our Leica scanner, our in-house scanner, and we did a little test. And after we'd done the trial run and had a look at the data, we were confident that we could use that tool to capture the data. The RTC 360 can capture 2 million points per second and has a resolution of 3 millimeters at a distance of 10 meters, a good tolerance for what we were trying to achieve. Its speed, accuracy, and portability and ability to register the data in the field all lent itself to the task in hand. Whilst we were confident the data we captured would satisfy our clients' requirements, it still wasn't without its challenges. We estimated it would take about 600 scan stations to capture the bridge in its entirety. And in order to capture the clear data we needed, the weather had to cooperate, which is not something we associate with Nova Scotia. So we had to pick our days. And as you can see from at least two of the shots in the slide, confined spaces can also prove to be a challenge. If you've ever driven across the bridge, then you've inevitably been caught in traffic and felt the movement, the sway of the bridge. The towers will move anywhere up to 3 feet, but it's designed to do that, so don't panic. That's why structural engineers stay awake at night. But fortunately, the VIS, or Visual Inertial System, a video-enhanced inertial measuring system to track movement of the scanner position relative to the previous setup in real time, is a feature on the scanner model and was able to combat the vibrations and movement of this huge structure. And this further vindicated our choice and decision to go with this tool. When we captured all this data using the scanner, what is it and what can we do with it? Well, as you can see from this shot, it's a point cloud. It's a digital representation, a snapshot in time of the asset, a digital twin, as it's often referred to these days. This is a plan view of the point cloud. And here, we'd scanned all the ground areas on the Dartmouth side and most of the ground areas on the Halifax side. And we'd also scanned along the sidewalk, although it's not really sort of clear at this scale, admittedly. This shot shows the same plan view, but all the yellow triangles, I call them Swiss cheese there, they indicate each and every station that was required to capture all this data. And all this data is not overselling the amount either. We vastly underestimated the amount of stations required. It ended up being over 1,500 setups and over 220 gig of data. Even using Leica's compressed LGS file format, it was a huge data set. So point clouds, usually the primary reason for utilizing a laser scanner is that's the data you're after. And it's a format that can be brought into a modeling environment to assist in model creation or model validation. So this is not the only form of data captured with the scanner, not this model anyway. So top right image is the actual point cloud, and it uses the color taken from the high dynamic range imagery. And if you zoom in on the shot, you can see a measurement that we took of the sidewalk. The high dynamic range imagery can be seen in the bottom right image. It effectively offers a virtual site visit, something the client often takes advantage of, whether they're having a chat with the O&M crew in the morning, walking through the daily tasks, or simply using it as reference. I know this is an aspect of the data that they really enjoy. And then the bottom left just shows another way to interpret the data using a hue color. In the point cloud file format, we can adjust the color intensity to best display the existing conditions. In the top right there, you can see a monochromatic grayscale view. It's often the best way to interpret data in darker areas. You can see there's better contrast there. The hue color on the bottom left shot, also useful where there's very little light, gives you a lot of contrast and makes things a lot clearer. And in the bottom right, you can see the same shot in the high dynamic range imagery, and you can see how dark it is. And whilst it's a realistic view, it's probably not the clearest way of interpreting the data. So these are the features that became very useful when discerning the components in the BIM modeling process. Again, a shot using the multi-hue rainbow mode of displaying the scan data, which can provide, like I said, great contrast for clarity in discerning the different elements within the point cloud. It's the same point cloud image here, but again, taking the color from the high dynamic range imagery. So it looks pretty realistic. And again, here's the high dynamic range imagery, effectively a virtual site visit. You can see my technician hiding behind the railings there in a car going on the bridge. This is a fly-through of the point cloud, and we'll give a clearer picture of the point cloud as a whole. The red dot there in the middle of the image is an indication of a scan station. And here we're just going through the deck of the bridge. As we go through the deck, you can see some of the data wasn't there because we hadn't actually done under the bridge in the catwalk areas at this time when I recorded this video. The resolution's a little off because I recorded it over VPN on my laptop whilst the data was residing on a server in our downtown office in Halifax. But it's pretty clear and you get the general idea. So as we spin around here, we'll return to that setup location and back to the high dynamic range imagery, the high definition. There we go. Lovely shot. So scan data captured, registered, and published to a point cloud. What now? A 3D BIM model. So we agreed with the client that we would model the bridge to an LOD 200, like a schematic level of development. Now this means we would model all the components that make up the bridge as defined by the client, the components that they wanted to ensure they were maintaining as part of their asset. It turned out in the end to be pretty close to an LOD 450 model, simply because my BIM technician couldn't help himself. But the client was really pleased. The results were stunning. Before we could get started with the model, though, we had to make sure that it was in real-world coordinates. Typically in Nova Scotia, Typically in Nova Scotia, it's NAD 83. This speaks to the asset management solution. Remember this, because we'll touch upon it towards the end. In order to start the BIM model prior to scanning, we used the original 1950s drawings and several upgrade projects that had happened over the years. We were given those drawings as reference from the client. So we actually started the model with the original construction drawings and started building from there. And then later on, we pulled in the point cloud into the modeling environment in order to validate the BIM model. Here's a few slides showing this, screenshots from the Revit environment with the point cloud linked into the modeling environment. This is an aerial view of the approach to the Dartmouth main tower. This is a little bit further along in the same area, and you can see it sort of developing and the point cloud adding into the environment. And here's a closer look at the DCA foundation on the Dartmouth side. Here you can see the concrete block. It's highlighted in the Revit environment. And here is D1. This is the first foundation on the Dartmouth side of the harbour. And this is a shot of the completed bridge BIM model. And as you can see, we did the street lights, we did the signs, above with the lights, every little component. Stunning model. Really, really proud of it. This BIM model, upon completion, is going to be used, as I said, for asset management. The data contained within the BIM model is exported to an asset management database. And this allows the Halifax Harbour Bridge operations and maintenance crew to survey the bridge or the asset. And using handheld tablets and field apps, they can view the bridge in the foreground. And then our model is actually in there as well in augmented reality. So if you've ever played Pokemon Go, you'll know what augmented reality is. And if they see a problem on the bridge, they simply touch our model, dialog box pops up, they type in what the issue is. That goes to a cloud-based asset management solution, which then spits out work packs and inspection and field reports for the O&M crew to then go and fix it. Now, I mentioned earlier we've done it in real-world coordinates. Why? Well, with an asset like this, there are a lot of duplicated components, a lot of similar steel beams and things like that. So the fact that we did it in real-world coordinates allows every component to have its own geodetic location. So this mitigates any confusion when the O&M crew then go out onto the bridge to address the issues that arose during their earlier inspections, and allows them to do preventative maintenance. So the larger image here shows the bridge brought into Esri Canada's asset management software. They're the company that's been tasked with the database required to spit out the work packs and the field reports. And the BIM model, if it's kept current, can be used by the owner to design and plan future construction projects, organize site laydown areas, construction sequencing, that kind of idea. The beauty of BIM, of course, being that the data is all centralized, accessible, and so it has value to the client beyond any construction phase. Asin Chowdhury, the chief engineer at the Halifax Harbour Bridge Commission, he coined this lovely acronym BIMS, Bridge Information Modeling and Management Systems. Looking forward to seeing the final results of this asset management database and moving on, doing the Mackay Bridge, the second bridge that spans the harbour in Halifax. So I hope that I've presented something that's of interest to you today. My challenge to you is finding a way of leveraging today's technologies, taking the principles of BIM, using all that centralized data and creating efficiencies on your projects, extending the life cycles of your projects for your owners and your clients. But before signing off, I'd also like to take the opportunity to thank Andrew Chow, my scanning specialist, and Gordon Bootlier, my structural BIM modeling specialist. Truth is, I'm presenting this, but they did all the hard work.
So Simon, we do have some questions, if you don't mind. I'm going to throw these at you. This is where we put you on the hot seat. It doesn't matter what your presentation said. So first question is, what asset management solution is being used by the bridge?
Good question. So Esri Canada are providing an asset management solution for the Halifax Harbour Bridge Commission. And I believe that it's part of their CityWorks software, which is often used for linear assets. I know Halifax Water, the utility here in Halifax, uses that as well.
Okay, here come the questions now. We've started it. So second question, what is the best way to manage massive sized point cloud files inside a Revit environment? For instance, if there's options for splitting them into smaller links.
Yeah, absolutely, Hamid. So you would have seen those slides where I showed the point cloud linked into the Revit environment, and there was just portions. The whole point cloud wasn't in there. So you can use section clip boxes, I think they're called, within sort of TrueView, the Leica software, and the CloudWorks plugin to the Revit environment. So you're not using the whole point cloud, because that can bog down the processing speed of your computers. So yeah, you definitely can do that. It's a good way to do it. I prefer using the LGS file format that Leica has, primarily because it compresses the files to a smaller file format, and again allows you to kind of spin around and regenerate those views as quickly as you need within the Revit environment.
Good answer. Next question, could the point cloud model automatically be converted into a Revit BIM model? And that's a loaded question, because I think everyone's looking for an easy button. That we take the point cloud, we open up Revit and hit that little magic button, and we automatically have an auto extract. I'm going to let you answer, Simon, because you use the tool, but as a sales rep, it's taking everything in me not to answer that question.
Yeah, I'm sure. So yeah, there are some scan to BIM software around. CloudWorks again has a software that you can use. I've done training with it, and I've used it. It definitely has its place. I think for something like this, for perhaps initially orienting your steel beams, for example, it's a good tool to use. I know that my BIM team at EastPoint, if they're doing a building, they find it just as easy to trace using the point cloud, creating clip boxes, creating plan views and section views and elevations, and just tracing the point cloud. They find it just as fast. But absolutely, there is a tool you can use to do the scan to BIM thing. I think it's probably a question of using it and getting used to it and getting up to speed with it. And I'm sure you would create and find efficiencies to using those scan to BIM tools. I've used a few over the years, and they all have their idiosyncrasies, some good, some bad. They will get you ahead. But I wouldn't rely on them entirely to do the entire bridge. I think there's still an element of tracing and detailing you've got to do yourself within the Revit environment.
Perfect. What are you using for the AR tool, and how is the tool managing drift?
Good question. I am not entirely certain. I'd be lying if I said I could answer that question, because that is really the Esri Canada piece of the puzzle. But I will happily get back to you and find that answer for you.
Perfect.
I meet with Esri on a weekly basis, so I will find out.
Here's a question. Why was the model made from a point cloud? Wouldn't one be made when the bridge was constructed? Well, I can answer that question. This bridge is 67 years old. So we're dealing with a very old structure here in Halifax. And there have been projects done on that over the years, but no one had delivered a completely new Revit model. So this was the first time that the commission had had a full model from start to finish that they could leverage for engineering and for maintenance. Sorry, Simon, I shouldn't have taken your thunder there, but I couldn't resist.
No, you're absolutely right. But
yeah,
and to be fair, we it was built in the 50s, so the Revit modeling wasn't around in those days. But we did use, like I said, the original construction 1950s construction drawings initially to get us going, and they were invaluable reference material to start the BIM model. The point cloud, we didn't really model from the point cloud. We used the point cloud for validation of what we create from the construction drawings. And obviously, it gave you the geodetic sort of sense. It gave you the location of the components within the asset.
And since you mentioned that, I'd like to add a question myself, just for the benefit of the people that are listening today. When you did the scan and compared that to those pre-existing models or drawings, how accurate were they?
Well, we had to do a lot of algorithmic data processing, a lot of cleanup, despite the fact that the RTC 360 registers the data on site. Because we're going on different days to scan, and because we did, 1,500 plus scans in order to capture the bridge, obviously there was movement. And once we got the point cloud into a format where we were able to view it, we recognized that there was a lot of duplication of the same components. For example, there would be like 3 towers. So we then have to do a lot of work cleaning the noise, as you call it, out of the point cloud to ensure the clarity within the modeling environment. So it wasn't just scan, register the point cloud, bring it into Revit and go. We did serious work on that point cloud prior to doing any modeling.
Wonderful. Did you have to elevate or extend the RTC 360 off the walkable areas for any scans, or did it remain stable if you did so?
Yeah, no, we just had it on the tripod, and we never really elevated it. We did go to the top of the towers, actually, and scan from the top of the towers because the client wanted data from up there. But still on the tripod, always on the tripod. We never elevated it. Sorry. It was the visual inertia system which accounted, like I said, for all the movement and vibrations and mitigated the majority of the noise for us. And then it was just part of the cleanup after the fact.
Perfect. And I do have a question that may be of interest to the folks listening today, and that is, what was it that initiated the interest in having a model to begin with? Now, we know that every owner would love to have a model. Usually there's a specific project that's challenging that kicks off a request for a model. And I'm just curious, did they come to you looking for this, or were they looking to solve a problem and this was your suggestion on how to get there?
Yeah, thanks for asking that. I perhaps should have mentioned this at the beginning. The reason why Halifax Harbour Bridge Commission approached us was because they were already dealing with Esri Canada. They were looking for Esri Canada to provide the asset management solution for them, and hadn't thought about the BIM model at this point. They'd given Esri Canada all the CAD files and everything they had digitally for the bridge. But once Esri Canada got those files and started looking at them, they recognized there was no Z value in any of them. They were all 2D files, which doesn't lend itself, obviously, to a 3D asset and establishing which component is where and that kind of idea, 2D was no good. So they went back to Halifax Harbour Bridge Commission and said, look, we really need to get a BIM model of this and bring that into our asset management database to provide the geodetic location. And that's when they reached out to me. It was the lack of Z value in the CAD files that gave me the opportunity to do this project.
Perfect.
Yeah.
Was the model built with links, families? How accurate dimensionally is the Revit model compared to the point cloud?
Yes, Jeremy. Yes, it was no links. It was all families, and we created all our own families. And in terms of accuracy, I would say, yeah, it's accurate to within 3 millimeters. It's accurate to within the accuracy that the point cloud provided. Yeah, it was really the tool that gave us the accuracy.
Perfect. And there's a question here from Debbie White, which was actually on my list next. And it was, how long did it take to scan and actually build the model? I was going to ask you to break it up and tell us, how long did it take to scan it? Once you had that point cloud, how long did it take to model it? I think to give people some idea of how long was this project from start to finish so that people can get an idea of scope.
Yeah, it's a good question. And I do have a spreadsheet of all the scans I've ever done and the time it took, number of stations, the memory size and all that. I don't have that at hand, unfortunately, Debbie. I'd love to give you that data. But I will say it's a 220 gigabyte point cloud in its LGS file format. It took us about 9 months, I would say, to complete the project. It was weeks of scanning for 1,500 plus scans. I want to say even a few months of scanning. Of course, the beauty being that we could scan, register data, start the modeling process with what we'd scanned already, and then keep adding to that master point cloud until we'd completed the whole job. So we didn't scan it all first and then model, because we had, like I said, the construction drawings to get the BIM modeling process started. We really used the point cloud to validate those construction drawings. And of course, the high dynamic range imagery is just beautiful for that too. You know, if there's something that's not clear on the construction drawings, because I mean, 1950s, these were hand-drawn construction drawings. You know, you could look at the point cloud or the high dynamic range imagery and validate what you were reading in these construction drawings to make sure that the size was indeed the right size member and things like that.
And I think, Debbie, I don't know if you're familiar with the Halifax Bridge we're speaking of. There are days that, because of weather, I don't believe Simon's team could even get on that bridge, and that bridge has a lot of movement. So windy days, they wouldn't be on there. So that would drag out the actual delivery time from start to finish as well.
And one of the things we didn't know was they have this thing underneath the bridge called a traveler, and the O&M crew use that, and it goes under the bridge. And if a boat comes along to pass under the bridge, the traveler has to go all the way back to the beginning. So this thing moves really slowly. So we would lose like hours a day when that would happen. And it's just something we couldn't account for. We weren't aware of. We didn't really budget for. And we, like I said, we totally underestimated by almost a third the amount of scans we would have to perform in order to capture the whole bridge. That's something I would caution you on, people out there. When you're doing your estimates and things, I would look at it time and time again. It's quite easy with a building because you've got a floor plan and there's no real sort of variables in that. When you're on a thing that moves and then you've got to move back because of a ship, you know, that's something you perhaps don't think about.